Alrighty, hi guys. So now we're going to go on to looking at what we call a two-tailed test. Now a two-tailed test, the main difference between a two-tailed test and a one-tailed test is where we were looking at a one-tailed test, we had our null hypothesis being the probability that say that x was equal to 0.3, and we had our alternate hypothesis as the probability, for example, that it was less than 0.3. When we're looking at a two-tailed test, we don't set this value as being less than or greater than. So if our null hypothesis is that our probability is equal to 0.3, our alternate hypothesis is now that our probability is not equal to 0.3. And the main thing that this does, it's called a two-tailed test because we're not testing to see whether it's greater than or less than a value. We're just testing to see whether it's not that value. So our actual probability could be bigger or it could be smaller. And the implication for this comes in to our significance level, because now we need to split our significance level between the two tails, so whether it's bigger or whether it's smaller. So for example, if we've got a 10% significance level and we've got a two-tailed test, that means that we're looking at 5% being less than, and we've got 5% greater than. Okay, if we've got 5%, then we're going to have 2.5% less than, 2.5% greater than. I think I'm doing that in the right way. 1%, 0.05 less than, and 0.05 greater than. Okay, so that's mostly where, like I said, that's mostly where it comes in. So that's the main difference. Other than just writing the null hypothesis, the alternate hypothesis is not equal to whatever the null hypothesis is. We then have to go through and decrease that significance level to reflect the fact that the probability could be either bigger or smaller. Okay, so we're going to look at this example here. So we set up our questions in the exact same way that we did before. Okay, so the very first thing that we need to write down is your test statistic and your probability. So I would say X is the number of people in the sample who order, I'm just going to write veggie, but you should write vegetarian, veggie meals at Enrico's. All right, our probability is the chance of a randomly selected cool. So from there, we then need to write down our null hypothesis and our alternative hypothesis. So our null hypothesis, we are suggesting that our probability is equal to 1/3, and our alternative hypothesis is that our probability is not equal to 1/3. Now the indication for you here that you are that you're doing a two-tailed test and not a one-tailed test is just the fact that, got an email, is just the fact that you're testing to see whether Manuel's restaurant is different to that of Enrico's. So it doesn't have to be bigger or smaller, it just has to be different. That's all we're testing for, and that's kind of your main indication. Alrighty, so if we assume that our H0 is true, which we then will do, so if H0 is true, our model is that we've got a binomial. X is a binomial, approximately binomial, with a sample size of 10. We've got 10 people and the probability of 1/3. Okay. Now we're testing at the 5% significance level. So therefore, we're expecting to have we could have 2.5% less than, 2.5% greater than. Okay, now from here, the next thing that we need to do is to set up our test. Now, in Manuel's restaurant, a random sample of 10 people ordering a meal. I ordered a vegetarian meal. So that's me being one person out of 10. So the probability that x is less than or equal to 1 is what we're going to test for. Okay, so we're looking at the probability that one person or less orders a vegetarian meal. And we're setting that up, so we're going to do this as a binomial CDF, or you can do a PDF and add. I'm just going to write it as So just for a bit of a recap, I'm going to write it like this. So we know that this together is going to be the probability where x is equal to 0 plus the probability where x is equal to 1, or you can use the CD, the binomial CD on your calculator. I'm going to use my big calculator just because I like it better. Escape, yes. Quit, yes. Okay, so I'm going to use binomial distribution, so CD, trials 10, probability is a third. Okay, x value is 1. Okay, and I'm using less than, paste. Okay, and I get 0.1040 as my probability, so 0.1040. Now, 0.1040, okay, is less than is greater than 0.025, 2.5%. So 0.1040 is greater than 0.025. So that means that if we were to reject the null hypothesis, we would have a 10% chance of being wrong. So therefore, as is greater than 0.025, there is insufficient evidence to reject null hypothesis. Okay, so therefore we can assume that the proportion of people eating veggie meals does not have enough evidence to suggest it has changed. Okay, or is different, or something along those lines. Okay, but all you just need is that conclusion at the end. We can't obviously say that the probability is exactly equal to a third. We just don't have enough evidence to say that it's not equal to a third, and that's what you're doing with all of the hypothesis testing that you do. Okay, have a go at 7.4. This is 7.4 now, so have a go at the 7.4 exercise, and then we're going to come back and we're going to do 7.2 after that. But I would suggest doing 7.4 first. Okay, thanks very much. Bye.